Audiovisual and Training Subcommittee of the International Association of Drilling Contractors Education and Training Committee and the Petroleum Extension Service of the University of Texas at Austin present Care and Handling of Wire Rope and Slings. This program would not have been possible without assistance of WellTech Incorporated, Bryden American Wire Rope Corporation, and the E.L. Bearden Company of Corpus Christi, Texas. Drilling and producing oil and natural gas. Whether the work be offshore, land-based, or on a workover rig, involves the use of strong strands of steel known as wire rope. Many different types and sizes of wire rope are used in oil operations. Without this important tool, getting oil and gas out of the ground would be impossible. One way in which wire rope is used on a rig requires stringing it over the crown block or top of the derrick, then through the traveling block, so that it can be used to hoist the drilling tools. We call this wire rope the drilling line. Wire rope is also used in crane operations and for slings. Air hoists on drilling rigs also use wire rope and are frequent victims of neglect. Some mooring lines that hold floating drilling rigs on location are also made of strong wire rope. Even though lives depend on its proper care and use, wire rope is one of the most abused pieces of equipment in the oil field. By learning good practices in the care and handling of wire rope, your job will be safer, you can reduce drilling costs, and the service life of the wire rope will be lengthened. For a better understanding, let's see how wire rope is made. The outer strands of any wire rope are made of steel. Grades may vary from rope to rope, but the main component is tough, strong steel. The inner core of the rope may also be steel or may be made of fiber. More about this a little later. First, let's see the machine that braids the strands into rope. This is a closing machine, and it does the job of manufacturing the wire rope. In the closing machine, the wire strands run through a series of offset rollers. This gives the rope a slightly permanent set and controls the rope's flexibility. This preforming process greatly reduces internal stress and makes handling easier. Preformed rope is less likely to kink when slack is on the line, will run through sheaves smoother, and will give a longer service life. Preformed rope is, in effect, dead, which means that it will be less likely to spring or jump when it is cut as a non-preformed rope will. The inner core supports the outer strands throughout the service life of the rope. The core of most wire rope used in oil field operations is made with a spiral that is opposite that of the strands. This balances the rope and offsets the tremendous torque that the rope has when under load. The core also determines the flexibility of the wire rope. The most widely used rope core in the oil field is the IWRC, which stands for Independent Wire Rope Center. IWRC ropes have a greater resistance to crushing than ropes with fiber cores. The fiber core is less expensive, but cannot match the strength of the IWRC ropes. However, the fiber core ropes do have more flexibility and are often used in swabbing operations. We've talked about manufacturing, preforming, and the types of rope cores. Now, let's discuss the outer strands. The grade of steel used for wire rope might be improved plow steel, abbreviated IPS. For stronger ropes, Extra improved plow steel, sometimes called XIPS, is used. Manufacturers of wire rope use different abbreviations for these grades of steel. Regardless of the type steel used, on the outside or of the type of core on the inside, all wire ropes spiral either to the right or left. This spiral is known as the lay of a rope. The lay of a rope is the direction of its spiral as the person views the rope from above. Shown here are 4 types of rope lays. The top 2 are regular lays, which means that the strands and the wires making up the strands are manufactured with opposite spirals. This strengthens the rope. The right and left labels indicate the direction of the spiral as viewed from above. The outer strands appear to be parallel. Remember that right regular is usually shortened to regular lay because of its wide usage. The Lang lay ropes have the wires and the strands spiraling in the same direction. Lang lay ropes are used primarily in industrial applications rather than in oil fields because of equipment design. Here is one view of a right regular lay rope. Note the parallel outer strands. This type lay is called regular lay around the drilling rig. Lay is also a unit of measure. One lay is the distance a wire strand makes in one complete rotation around the rope. This distance is measured in a straight line parallel to the center line of the rope. By knowing the original lay, wire rope can be measured and compared for signs of stretching and other abuse. For instance, a stretched rope will have a longer lay than the original measurement, but more noticeably, the outside diameter will be reduced. Let's examine the interior of the rope. A cross-sectional view will help in learning more about wire rope designs. Shown here is a representation of one strand in a wire rope. In this particular design, 6 wires surround a slightly larger wire in the center. These 7 wires make one strand. This pattern is called a 7-wire strand arrangement. When 6 of these 7-wire strands are closed around a central core, the rope is called a 6x7 wire rope, 6 strands having 7 wires each. This is a common wire rope construction for sand lines that are used in oil field work. Present-day rope constructions are highly perfected variations from the earliest and still commonly used design, the 6x7. Some wire ropes have as many as 91 wires per strand. Special wire ropes are available for a variety of jobs. This 6x41 design would probably be used for anchor mooring lines. The most common wire rope design is the seal design, named after its inventor. When the word seal is on the wire rope order form, it is an indication of the type of rope design. The outer wires in each strand of a seal design are all of the same size. The next inner layer of wires has the same number of wires as the outer layer, but they are smaller in diameter. When using wire rope, it is important that the correct size be used. To correctly measure rope, use a linear caliper that is marked in 1/64th inch increments, and remember to always measure across the crowns of opposite strands. Similar to this, it is always the largest measurement that can be made across the axis of a wire rope. Correctly measuring the wire rope will allow proper fitting in the sheave grooves. If the groove is too tight for the rope, pinching will occur on the outside and the core will also become distorted. A groove that is too large will not support the rope, which will tend to cut into the groove tread and become distorted. These effects greatly reduce the rope's useful life. A complete description of wire rope might include the length of rope, the diameter, the number of strands and wires per strand, the construction design, the type, direction, and length of lay, the grade of steel, whether preformed or non-preformed, and the type of core. So when you see a description like this, you should know that it means 5,000 feet of 1 1/8 inch diameter wire rope with 6 strands of 19 wires each, seal design, regular lay, improved plow steel, preformed, with an independent wire rope center. Regardless of the type of wire rope used, it must be used correctly. For example, winding the rope on a drum must be done exactly right. No overlays or slack at all. Correct winding helps prevent crushing and flattening of the rope. Shown here are an overwind and an underwind for a right lay rope. This view is from the rotary side of the drawworks. At the rig, an underwind for a right lay rope will look like this as you stand on the rotary side of the drilling line. Notice the even spacing and the direction of the rope spiral. This view is also from the rotary side of the drawworks. For a left lay rope, the overwind starts on the right and moves left. The underwind is the opposite. It starts on the left and winds to the right. Attaching wire rope to rig equipment must be done correctly. Here is the dead line equipped with wire rope clips. The clips give the line adequate holding power. They are evenly spaced, usually 1 clip base apart. There is a right way and a wrong way to install wire rope clips. The right way has the U-bolts pressing against the dead end of the rope, while the bases are bearing against the live end. The old expression, "never saddle a dead horse," is one reminder of the proper technique in installing wire rope clips. If the clips were incorrectly installed, damage could occur. The most likely result would be a kink in the rope. Needless to say, kinks shorten the useful life of any wire rope. In most cases, thimbles should be used in the loop eye of the rope when clips are used. Thimbles like these help prevent kinking. Also remember that sand and dirt can work into the core of the rope and can abbreviate the service life of a potentially long-lasting wire rope. One maintenance task that will lengthen the service life of wire rope is proper lubrication. Wire rope is lubricated as many as 3 different times during manufacturing. First, the individual wires are lubricated as they are laid together in the stranding machine, and then the strands of wire are lubricated as they are closed around the core. Finally, the entire rope is sometimes lubricated again before being spooled onto the drum. Monthly field inspections by the driller may reveal the need for additional lubrication, especially on the drilling line. When field lubrication is necessary, use a good grade of lubricant that is free from acids and caustics, and be sure the rope is clean before applying the lubricant. Several methods of field lubrication are possible. One method is to paint the lubricant on the rope using a brush. This roustabout has been lubing for so long, he can do it without looking. Your driller probably prefers that you use both eyes while you try this. Experienced drillers sometimes prefer to lubricate the drilling line during drilling operations. The brakes are applied and locked while the driller uses a good clean grade of lubricant. The results? A clean lubrication job that is evenly spaced over the entire line. Check with your driller before you try this method yourself. Running the rope through a field bath can also provide proper lubrication. Simple baths can be constructed at the rig site. The rope is lubricated by pulling it through the sheaves inside the bath. Excess oil is wiped off with a rubber cone to protect against cuts. The field bath is convenient when the rope is being spooled onto a reel for transportation to another rig site. These men are preparing for an operation known as seizing. Whenever wire rope must be cut, seizing is a must. To seize a wire rope, both sides of the area to be cut will have to be wrapped with wire. Never use tape to wrap. If the rope were to jump or become frayed while being cut, the tape would not hold the strands, and injuries to personnel could result. Even pre-formed rope must be seized before being cut. The first step in the seizing operation is winding a soft wire tie around both sides of the area to be cut several times by hand. The wraps should be kept together, and considerable tension should be kept on the seizing wire. Second, twist the ends of the wire together counterclockwise by hand so that the twisted portion is near the middle of the seizing. Next, using the proper type cutters, tighten the twist just enough to take up the slack. Tightening the seizing by further twisting is not recommended. Now, tighten the seizing by prying the twist away from the axis of the rope with the cutters. You may have to repeat the tightening and twisting until a secure, finished seizing is obtained. Cut the ends of the seizing wires and tape them flat against the body of the rope. The rope is now ready to be placed in the cutter. A solid blow with a sledgehammer will give an even cut. Hydraulic cutters are used on some rigs. Be sure you wear protection for your eyes when cutting the line. Drilling operations require calculations to determine length of service of wire rope. One term you should become familiar with is ton-mile. You will see and hear this term many times. A ton-mile is a measure of the weight and distance moved by a wire rope. When a drilling line has lifted 1 ton of drill pipe or casing for a distance of 1 mile, 1 ton-mile of service has been performed by the wire rope. Accurate records of ton-miles should be maintained with records of the date, depth, type of service, and any unusual conditions noted. A ton-mile record sheet like this one will enable you to know when to slip and cut the line in order to move the maximum wear points on the wire rope. The amount of service received from the line is also determined from this form. Ton-mile record sheets are usually furnished by the manufacturer along with a ton-mile calculator like the one shown here. Instructions from the manufacturer will help you use this calculator. The proper working load of a wire rope, particularly running ropes, should never exceed 1/5 of the rope's breaking strength. In other words, the safety factor, sometimes called the design factor, should be not less than 5 to 1. For example, a 7/8 inch diameter of 6 by 19 IPS wire rope has a breaking strength of 28 tons. With a design factor of 5 to 1, the proper working load would not be over 5.6 tons. As we have already noted, inspections at regular intervals are important in obtaining full service life from wire rope. Inspections also ensure that safe operating conditions are maintained around the rig. Checking up on wire rope may show a need to remove some rope from service. Examine the entire length of line for corrosion, broken wires, kinks, or other damage. Let's look at some signs of abuse in wire rope. One common sign of wear are broken wires. Many causes may be responsible for this type of wear. For example, fatigue from excessive bending over small sheaves or reverse bends can lead to this condition. Also, a collapse of the core due to overloading or excessive rope speeds can produce the same result. Always stay within safe working load limits. If a load is released too suddenly, bird caging like this may result. Remove any bird-caged wire rope from service. Overloading, external and internal corrosion, or excessive abrasion can cause a marked reduction in rope diameter. This reduces the original strength of the line and is a warning sign to discard the rope from service. When the rope is wound onto a drum for moving, the line must be tight with no gaps or loose winds. The results of an improper wind range from crushed rope to kinks and rust. Gaps in the wind cannot be allowed. The rope will be crushed when the next layer crosses back over this gap. However, do not use a hammer to maintain a correct wind onto the drum. Damage to the rope will occur, its service life will be shortened, and flying steel chips could cause serious injuries. Avoid this method of winding onto a drum. Overstressing can cause frayed and broken wires. This type of damage can be caused by too rapid an acceleration of the load, a sudden jerk, or the impact from sudden stopping of the load. Poor socket design, or a socket that is consistently overloaded, can cause a failure at the socket. Watch for signs of wear and abuse of wire rope, and remove such lines from service. Sheaves are an important part of the wire rope system on a drilling rig. The correct sheave must be used for the specific size of rope being used. Here, a driller makes sure that the drilling line will fit the sheaves at the top of a derrick on a workover rig that is about to be raised. To correctly measure sheaves, a sheave gauge similar to this one should be used. It is a precision instrument that has the various diameters of sheaves clearly showing on each different measuring gauge. Your work may involve the use of slings, like the ones shown here. Slings are made of wire rope and deserve the same care and maintenance as any drilling or hoisting line. Let's look at some slings that might be used on your rig. A sliding choker hook is often used to attach a sling to a load. The load end of the sling fits on the sliding choker hook, and the upper end of the sling is slipped over the hoisting hook. The choker hook is designed so that it grips the load when lifted by the crane or hoist. A bridle sling is made of 2 or more plain or choker slings of equal length, with the legs attached to a pair link like the one shown at the top. Like all wire rope, slings must be inspected regularly to prevent accidents and extend service life. When inspecting slings, check for corrosion and broken or kinked strands. If a sling looks defective or in bad shape, remove it from service immediately. When using slings, watch out for low angle tension. This occurs when the sling makes too low of an angle with its load, which causes an increase in tension. Shown here are 2 1,000-pound loads. At the left, a single sling would have 1,000 pounds of tension. However, if the weight is divided equally by 2 slings, as in the load on the right, the tension is shared equally. Note that the slings make a 90-degree angle with the load. However, when the legs of the slings are angled at 60 degrees, the tension increases. At the left, the angle has been decreased to 60 degrees, making the tension on the slings 575 pounds on each leg. At the right, the angle is decreased to 45 degrees, which increases the tension to 705 pounds on each leg. As the angle decreases, tension increases. When a 30-degree angle is used, tension is 1,000 pounds per leg. At 5 degrees, the tension is 5,735 pounds on each leg. It's easy to see why slings should be set to avoid low angle tension. When using slings, be aware of sharp edges that may cut the rope. Place protective pads or wooden blocks between the load and slings to protect against sharp edges. A wire rope under tension is easily cut. Moving large pieces of equipment is an everyday job on most drilling rigs, especially offshore. Be sure you use a tag line to control the swing and placement of large, hard-to-handle loads. Always store slings in a clean, dry place when they're not being used. preferably on a rack. A shed is a good place to keep slings orderly and dry. Lubricate the slings to keep them in good working condition. One of the most important don'ts of slings is never use a manila rope to make a sling. This type rope is not strong enough, even though it may look like it could handle the load. Don't take risks. If loading eyes are available on equipment, use them. This will make lifting easier and, above all, safer. Sometimes you may have to lift a load that is built so that the sling's legs may crush the upper part of the load. One example of this is a skid-mounted building or compressor. By using a spreader bar, the sling legs are kept a safe distance from the crushable load. The spreader bar protects the slings as well as the load. Hooks with safety latches are important when using slings. Safety latches are required on hooks used for personnel lifts. Make sure your rig follows this important safety regulation. Remember that the eye of the sling is usually the point of greatest wear. Use the proper sling fitting to shield this area from abrasions and abuse due to lifting excessive loads. Wire rope is widely used in producing oil and gas and is often abused. Check the wire rope before it's used for drilling, hoisting, or for slings. Remember that proper lubrication will prevent corrosion, and inspect wire rope and equipment regularly so that it can be replaced if necessary. By doing these simple maintenance tasks, your rig will be safer and your wire rope will last longer.